Ready.
Hi everyone, I'm Lynn Trong with the National Renewable Energy Laboratory, and I'd like to welcome you to today's webinar hosted by the Building America program. We're excited to have Lena Burkett, Steve Brown, and Todd Usher with us today. Before we begin, I'll quickly go over some of the webinar features. For audio, you have two options. You can either listen through your computer or telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. By doing so, we'll eliminate the possibility of feedback and echo. If you select the telephone option, you should already see a box on the right with a telephone number and audio pin to use to dial in. Panelists, we ask that you please mute your audio device while you're not presenting. If anyone's having technical difficulties with the webinar today, you can contact the GoToWebinar's help desk for assistance. And throughout the webinar today, please use the questions pane to type in your question. Also note that we are recording the webinar, and we will be posting the PDF copies of the presentation on the Building America website. Today's recording will also be available within a few weeks on the DOE YouTube channel, and then you can also find that as well on the Building America website. Before our speakers begin, I'll just provide a short overview of the Building America program. Following the discussion, we'll have a question and answer session throughout the webinar today. And then we'll wrap up with closing remarks. For more than 20 years, the U.S. Department of Energy Building America program has been partnering with our industry to bring cutting-edge innovations and resources to market. Today's webinar is a more informal presentation of the information that we usually present to you through our Building America webinars. And we hope that throughout the time today, feel free to submit questions. We want you to ask whatever is top of mind, anything that you would like our experts to respond to. So let's go ahead and start with today's webinar. Moderating the question and answers today is Lena Burkett, who is a fellow at the Building Technologies Office with DOE. We also have Steve Brown, who is the owner of Carl Franklin Homes. He is a third-generation lumberman and builder with more than 40 years of experience. He began building homes in the Dallas area in the 80s, and a few years later he started and changed his course to build construction, to change the course of his construction business to build only extreme energy efficient homes. Todd Usher is founder and president of Addison Homes. He was the first builder in the United States to earn the National Association of Home Builders Master Certified Green Professional designation. Todd is also president of the Home Builders Association of Greenville and is back in 2008, and he was also the NAHB National Director and South Carolina HBA Education Chairman. They'll be speaking more to their experience and their expertise and their background today. So with that, I'll hand it over to Lena to start today's discussion.
Thanks, Lynn. Hi, everybody, and welcome to the second edition of Stump the Building Science Chumps. This edition is, we invited two builders to represent a builder panel for our audience. This is the second iteration of this. Our first one, for those of y'all who tuned in, was with building scientist Joe Stebrick. So we kind of got the an expert kind of research opinion first, and now we're going to kind of take some of these questions out into the real world and see what real builders have to say about them. So
I have to laugh. Real builders.
Real builders.
I'm sorry. Real builders. Okay.
All right. So Steve, Todd, thank you all very much. Is there anything else you want to say to introduce yourselves?
Well, I'm reading Todd's stuff, and I'm impressed. So Todd, I know you, but hey, you still impress me by reading all this. Looks great.
Well, same goes for me, Steve, and but I guess we're both officially chumps as part of this
Absolutely. Absolutely.
Chumps in you know the highest of respect.
We're real
right.
popular among ourselves.
Yeah, little,
Okay.
our little group of building science nerds, right?
That's right.
Exactly.
Todd and I see each other. It's kind of like when we're at any kind of a meeting where both of us are there. It's the same little group. There's just not that many of us, but
Yep.
we know each other pretty well.
Good. That's good. Well, I don't think that I've had the pleasure of meeting either of y'all in person, so I'm trying to get your voices straight. But see, y'all both have those Southern accents. Now, I should be used to it
Yeah.
because I grew up in Texas and I went to grad school in North Carolina. So
Okay.
I think I'll make it through. Hopefully others on the line aren't too perplexed by your accents. So we'll get started. This one goes out to both of y'all. We'll start with Steve. So what first got you into the home building business in general, and then more specifically into the high performance building and energy efficient homes?
A third generation builder. My grandfather actually cut railroad ties for the railroad. We had sawmills, we had hardwood flooring plant, we were in the lumber business, and building just followed right along with us. We actually back in the 40s and 50s built housing for the people that worked for us at our hardwood flooring plant. So I grew up in the industry, and it was just second nature for me. But once I got in it, I was one of a million. I mean, everywhere in the Dallas market, there's every time you turn a leaf over, there's a builder under it. So I had to find something that separated me from all the rest, and I decided that energy costs weren't going down. There had to be a better way to build a house, and so that's what started me off in the energy efficient and green building.
Great. That's so interesting that your company, your family's company, started out building homes for the employees.
Exactly. Yeah.
That makes a lot of sense that you have to find a way to differentiate yourselves in that market. I know that Texas is one of the fastest growing home building markets in the nation.
And our association here, the Dallas Association, is probably one of the largest in the nation also. So there's, like I said, everywhere you look, there's a builder. So what makes you different from the next guy? And years ago, I took a path that led me totally. Matter of fact, I had a building partner who decided to go into the high end, and I decided to go into the low end and try to perfect some type of a system that would build an energy efficient home, and tried it on the market that has the least amount of expendable income at the end of the month, which is the affordable market. So that's where we actually cut our teeth in this industry.
Great. Okay, Todd, what got you into the home building business in general, and then more specifically high performance?
Yeah, my track was a little different. I went to college at Clemson University in South Carolina, and actually got an undergraduate degree in packaging. Then went to work for a chemical company for about 8 years. And while at that chemical company, went back and got an MBA and decided I wanted to invest in real estate. So started buying a couple of rental houses and started fixing them up on the side, and just fell in love with getting out of my suit and tie and working on houses on the weekends, and kept working in the corporate world for a number of years, just kind of frustrated over how I could make the move to building or construction full time. Back in the late 90s, I started flipping some houses on the side, but actually had a builder's license and was doing it the quote unquote right way, where there were a lot of house flippers that were just putting a coat of paint on it and making it look pretty. But ironically enough, when I finally made that move, the chemical company that I'd worked for was a Malcolm Baldrige Quality Award winner back in the late 80s, and had really implemented a number of kind of forward-thinking practices, zero landfill policy. The owner of the company was a tree fanatic, So most of our chemical plants were essentially like arboretums. And that, I guess, what was pounded into me in my corporate life and training was follow best practices, and sometimes what's good for the environment is good for business too. So when we started building new houses after I left the corporate world, I was looking for the quality standard, the best way to build a house, and kind of lucked upon a regional green building builder training program, which was a program called Earthcraft House. And, all of the specs and the details for how to build a high-performance home just made a lot of sense. And for me, that was kind of an aha moment to say, you know what, this is going to be our quality system. And that was back in 2002. And we were in the process of building our first custom home at the time, and decided to implement the Earthcraft House and Energy Star program as kind of a test. And lo and behold, the house was one of the best performing houses that we had heard of at the time after we built it, and the homeowners had low energy bills and great comfort and good indoor air quality, and that just became our standard. So we've continued to, I guess, up our game as the market and the energy code has improved or has taken steps. We've continued to push to more and more higher performing construction practices. But truly, we found that building high performance not only differentiates ourselves in the market, but is also great for our business.
Great. Well, that's a pretty windy road to get you to home building. But I myself have a windy path as well. Starting out as I saw that you had a degree in packaging, which I hadn't seen before. My undergrad, I think, was even further kind of out of this field, which was philosophy, and then worked out in the field doing construction, residential construction for a few years, and energy rating, and then went back for a master's in building science. So I think, some of us are kind of know from the very beginning that we're going to be in this, and some of us kind of take a windy path. Okay, so
well,
we're going to jump into...
It's interesting and fairly ironic. I still say I'm still in the packaging business. I'm just packaging people. Yeah. Far more durable.
Oh, there you go.
Yeah, definitely. Okay, so we're going to jump into some of the more technical questions. This one came from emailer. It came to our Building America inbox. She says, at a meeting recently, the question came up regarding how important and what is the value of correct sizing on heating systems with regards to newer high-efficiency systems. Since the off-cycle losses are minimized by the more efficient technology, what other benefits can be achieved by correctly sizing equipment? Systems that advertise themselves as high on comfort seem to be deliberately building in short cycling to minimize temperature swings. And I will just open that up to either one who wants to start out.
Well, I'll jump out to begin with and say that a HVAC system, like a car, you get the best gas mileage when you're on the highway and it's running. Same thing with the HVAC system. Kicking it on, kicking it off with a standard compressor, it takes a lot of juice to fire those things up and get them started and to in the first few minutes of running. Then when they go into their different cycles, that's when they become economical. So if you downsize or properly size your HVAC system, it's designed where it will actually run longer. But the longer it runs, the more efficient it is, and that's the point. Used to we thought that every house had to have a ton per every 500 square feet. It's kind of standard in the industry years ago, and it was hard in the beginning when we started into the energy efficient construction and the use of these more energy efficient HVAC systems to get your contractor to actually change his sizing requirement. They wouldn't warrant the product. They said, you're not, especially in our part of the country, in the South and in Texas. We here in Dallas, we wake up to about 75 to 80% humidity and drop down into the 40% during the day. So we're hot, but we're not hot humid, but we're mixed. And you've got to get rid of that moisture, and you've got to cool a house down. And when it gets hot here, 100, 105, you've got to have the right kind of HVAC system and the right insulated home, which is the key factor to make these things work and work economically. Otherwise, your utility costs are just outlandish. So properly sizing, and in my case and in Todd's case also, we downsize. We're with the energy efficiency of our wall and roof systems and basically our energy envelope, we don't need as much HVAC to heat and cool. Also, especially for my type of construction with structural insulated panels, we're like a styrofoam cooler. So you get us cool, we stay cool. You get us warm, we stay warm. And we don't have the peaks and valleys that the older homes that have little insulation and aren't sealed well. We don't have those peaks and valleys of heating and cooling. So if you look at a chart for our cooling specifically, we kind of roll. We don't peak out. We just have a gentle roll. We'll warm up a little, and then when you cool us back down, we stay cool longer, simply because of the energy envelope. So I just don't need as much HVAC as the older homes do.
Right.
Todd, how about you?
Yeah, I mean, we're in South Carolina, so we're climate zone 3. Steve, are you 3?
Yeah.
Okay, so we're both in the same climate zone, mixed humid, hot humid. We're cooling for the majority of our season versus heating. So our strategies for cooling are primarily focused, like Steve mentioned, on dehumidification with the air conditioning system and space cooling. We construct our homes a little different than Steve. He does structural insulated panels. We do traditional stick frame walls, but we sheathe the exterior of our walls with foam board. So in many respects, we're kind of creating a similar thermal envelope to Steve, probably not quite as robust, but we're wrapping the outside of our homes with an insulated blanket, kind of like that styrofoam cooler, and we see the same thing. The majority of our homes today, we are using variable speed heating and cooling systems, heat pumps to be specific. And, the benefits of variable speed systems is just like Steve mentioned. It's like driving your car on the interstate versus driving your car in the city. It's far less stop and go, stops and starts, and more extended run times where that unit's just adjusting to match the load in the house, which in our case is pretty minimal. One interesting thing that we've noticed is in building high-performance homes, that whole pie of energy use in the house, where heating and cooling in a traditional home is probably 50% of the pie. And in our new homes, we find heating and cooling cost is probably more like 25% of the pie, if not sometimes less, depending on our foundation type, basement or slab versus crawl space. But those benefits, result in vastly improved comfort. And we're not really deliberately, I guess this question said, deliberately building in short cycling. We really don't want short cycling. We want longer run times.
There you go.
And especially where you are in South Carolina, even more so than Texas, you're gonna be dealing with those really high humidity days. And yeah, if your HVAC contractor, if you're having a hard time convincing them that because of this higher performance envelope, they don't need to use that old rule of thumb, then you're going to have some complaints from your homeowners about the humidity level in their house. So we've got a question coming in live from one of the attendees. This says, and if anyone else would like to add a question, you just go to the question pane on your screen and type in your question. This question says, as high-performance envelope builders, how do you view the passive house standard? I'll open it up to either one.
I'll take that one, and I have to say that I'm a little naive to the passive house standard. That's on my my to-do list is to attend a passive house training. I think though in our market and our business model, we're trying to bring higher performance to as many folks as we can, and in doing so, trying to drive the cost of building higher performance homes down so that we can reach a larger percentage of the market. I'm not so sure that passive house for us would fit in driving that cost down. There are definitely some great benefits of passive house. You know, pretty amazing thermal envelope performance. I just have to say we haven't explored it in depth to be able to give you a good answer on that.
We're the same way. It's not something that we're going to breach in our market. It's worthwhile. I think there's a future for it, but right now the main line is a superior energy envelope and more efficient functioning equipment. Here again, like an HVAC system, we've gone to inverter driven. We don't have all of our compressors now that we use. We go with a inverter driven system, DC power. They run on a fraction of the cost. They ramp up, they ramp down real quick, and the performance we found to be superior. So they cost a little more up front, but the performance and the life expectancy of it, especially in the superior energy envelope like Todd and I build, and Todd, the statement you made the other day just a few minutes ago about our building envelopes are different. We both get to I believe we both get to the same place relatively, just using different methods. So our goal is to build that superior envelope, and there's a lot of different ways to do it. We just happen to be a SIP builder, and because quite frankly, it's such a forgiving envelope. When we screw up, we just don't know it usually. So, but here again, the efficiency of the equipment, mainline homes, the things that we do, like Todd, we're trying to sell to the general public in passive house right now. To us, there isn't enough of a market there to really delve into it. And I'm also like Todd, I need to study up more on it.
Sure. Okay. So do y'all know of any builders in your area that are building passive house?
None in my market.
None in my area.
So it may be right now kind of a
either.
regional thing where no one in the hot and humid and mixed humid climate areas are demanding that.
Exactly. I would certainly think it would be.
Mm-hmm.
It would be more of I wouldn't say just so much a northern product, but
there's more of a draw.
I don't know
if you
that
have a higher heating. If you have more heating than you do cooling.
Exactly.
Certainly could be the case.
And this could be just a guess, but my impression is that most of the passive homes have been built in colder climates. With our building and our climate zone, Steve, probably very similar to this, we're already on the borderline. Not that passive house can't handle this. There are strategies that can handle this, but with our envelope, we're already on the borderline where we're having to take a really close look at moisture management in the form of humidity management in the shoulder months, spring and fall.
Mm-hmm.
Yep.
Building an envelope so tight and insulating it so well, the risk kind of becomes, all right, what if we don't have a cooling load so that AC unit's not going to run and dehumidify the house? We've got 70 degrees outdoors, and the set point on the indoor thermostat's 70 degrees or 72. How are we going to control humidity? And that's probably more of a concern in our climate zones, being mixed humid, hotter, more humid climates than it is in the northern climate zones for sure.
Yeah.
Sure. That makes a lot of sense, and you bring up a good topic on that dehumidification. It sounds like so far you're able, but you're just kind of on that edge of being able to handle all of your dehumidification in the typical HVAC system. Have you had any projects where you had to bring in a separate dehumidification system? And if so, how did that work out for you?
Well, I would say I would qualify that in a couple of ways. So one note that you made was, we're kind of borderline with a typical HVAC system. I would say we're not borderline. We would not work with a typical HVAC system very well.
Sure.
A typical speed system is probably not going to handle the moisture humidity load in the house. The variable speed does a fantastic job with that.
Mm-hmm.
We have added dehumidification to some homes. In particular, it's very interesting because I think it's more of a what I have noticed is a lot depends on occupant behavior, from primarily where the occupants keep their set point on their thermostat. So we've noticed in particular certain cultures from parts of the world where air conditioning is not the norm and hot climate is the norm, we find that they keep their thermostats set much higher. And that's where we tend to see more of that potential indoor humidity risk. So if someone's not running the air conditioning a lot, if they're keeping the set point on 78 degrees or 80 degrees, then humidity might be more of a factor in their home.
Yeah, and
right.
to follow up on that, Todd, we also see the same thing in different cultures. When you build for different cultural values and lifestyles, there are, for instance, in some you'll have cooking that goes on all day long. Even when the family is not around, they'll have something that'll be cooking on a stove that's letting off a lot of moisture, and so all you're doing is just pouring moisture into a house, and you've got to get rid of it. And we have found over the years how to handle that with our HVAC systems and with venting over the oven range, and we've also been very lucky with different types of systems. Todd and I both use variable speed equipment, heat pumps, but the inverter-driven type we found is very good. We've used the high-velocity, low-volume mini duct system. We've used ductless systems, and we found that all perform well in a highly insulated home. That's here again, the energy envelope is the key. Everything else can kind of fall into place after that. You just tweak the other parts to it. But the moisture content, and one of the things we find, especially since we build a majority of homes for the workforce housing industry, is that workforce buyer tends to open windows and use outside ventilation more so than maybe other types of buyers that might control their environment through the HVAC system. Whereas if it's a cool day, or if in fact you have a storm blowing in, it's always cool before the storm. It's that moist air, and you'll find that a buyer will open the windows and let that cool wind blow through a house, but that cool wind has a lot of moisture in it. Now we shut the windows, and I've trapped all that moist air inside my house. I've got to get it out of there. So the only way to get it out is through the HVAC system. And so here again, longevity and running helps work it. A larger coil, running the air slower across the coil takes more moisture out. I mean, there's different ways that we do this, but Todd and I both have to deal with these things. And sometimes you build a home and you find out systems don't work the way you thought they did. You've got to go in and readjust and make them work. So that's all part of the industry too.
Right. Okay, so we've talked about heating and cooling and dehumidification. So right on the heels of that comes a question from one of our audience members about ventilation, and that was one of my questions too I wanted to ask next. So he's interested in the balance of cooling, dehumidification, and adequate ventilation, tight envelopes. What equipment are you using? And I'll just kind of broaden that out to kind of what types of ventilation strategies have you used recently? Have you found work best with your building style and all the other components in your homes?
For us, we've had to use in building a tight envelope. They don't breathe like older homes do. So we have to bring in fresh air. And in bringing in fresh air, there were always two systems. There was the HRV and the ERV. The HRV was the heat recovery ventilation, which was used more in the northern states, and the ERV is energy recovery ventilation. And so that's what we use down here. We still do. We have to bring fresh air in, but we've devised a system along with our HVAC contractor who actually came up with it. It's a type of an ERV, but it works off of its own small motor and brings fresh air in because we all have to meet the ASHRAE 62, I think it was the 62.2 requirements for fresh air volumes or fresh air turnovers in homes. So you got to keep your air fresh because the house has to be healthy. But here again, in these systems, our HVAC contractor handles that for us. The ERVs, the typical ERV, they were really expensive. I think they started off, they were around $1,500, which might not be a lot, but when you start into the workforce housing, that tends to be a pretty big lick. So we devised our own way of doing it, of bringing fresh air in. We locate the fresh air intake in specific areas. I won't tell you where that is. That's kind of a trade thing for us. And by the time we run, yeah.
Come on, Steve. Tell us where you put it.
Todd's trying to pull the trade secret out,
yeah,
out
sure.
of you.
Yeah, I'm not telling anything. but here again, remembering when on our homes, the type that we build, we have an insulated, our attic is insulated space. So everything under my roof is conditioned air. And my attic space runs maybe a degree, 2 degrees at most, warmer in the summer than the rest of my house. I circulate my air all the way through the home. So my attic space is conditioned. And by bringing outside, here again in our temperature, hot air, and running it through a certain amount of ductwork, insulated ductwork that is set up in this attic space that's conditioned, I'll pull 100-degree outside air down to about 84, 85 degrees by the time it hits my HVAC system on the fresh air. So in doing that, now all my air conditioning system has to do is cool from 84, 85 degrees down into the 70s, which is a whole lot better and a whole lot easier on a system and works so much better than having to cool it from 100 degrees. So there's tricks to the trade in what Todd and I do, but here again, it's very common sense evaluations of fresh air returns. And here again, while we're doing all this, we're taking moisture out of the house, which helps cool the house.
Todd, do you have anything to add?
We have used ERVs, energy recovery ventilators, in the past, but our primary, just like Steve, I should say first that when we build a tight envelope, we have got to bring fresh air in to maintain indoor air quality. So the keys for us from a ventilation strategy are point sources of indoor contaminants or pollutants. We want to make sure we're getting those to the outside. We're getting them out of the house. So in our humid areas, in our moist areas, that being bathrooms with a tub or shower, we'll have a bath fan, and we'll put that bath fan on a timer switch. And we teach the homeowner that, our recommendation is they set that timer on 60 minutes and they let it run. They don't have to worry about how long to leave the bath fan running. They just set it and forget it. Let it evacuate the moisture after they shower or bathe. Range hood is the other vent source that we want to make sure we get to the outside. And the programs that Steve and I build to, we're testing those ventilation sources too to make sure that they have a minimum required airflow, to make sure we're getting the correct airflow out of those locations where we've got potential indoor air quality contaminants. But then on HVAC, where our fresh air strategy is predominantly a positive pressure strategy in the house. So we're bringing in fresh air from outside through the return side of our heating and cooling system. And then we use central filtration in our HVAC system. So our filter is at the unit, and we're typically using a MERV 16 filter with our go-to air filtration system is a Lennox Pure Air filter, which is a MERV 16 filter and a purification element that does photocatalytic oxidation. PCO purification is the abbreviation for that. So that fresh air is getting filtered as it's brought into the house, and we're essentially positively pressurizing the envelope and letting the stale air exhaust out through those exhaust fan locations.
Right. Okay, great. A lot of really good information on some different ventilation options. So we're going to move from the equipment side to the exterior envelope side. So this was a question that came through the email, and I like how this is phrased. How really important is it to float on furring strips, horizontal lap cement board siding above the underlying zip sheathing in order to provide a drainage plane behind the siding in our Zone 4 location? Now, I know that y'all are Zone 3, but I think that y'all have some, some awareness.
I've got an opinion. We don't do it, and although we should, well, I shouldn't say we should. Joe would tell you, Joe Steeper would tell you that you need to do that, and it's probably a good idea. It's never really. We have done it. We don't see any difference in doing it either way, except there's a little more cost in doing it this way. And here again, there's a little more learning curve to a subcontractor to do it. But we've pulled siding off of houses that we've done, oh gosh, 18 to 20 years ago. And we don't see any type of problem. We just don't have that problem. It may be more predominant in a more humid climate, but for us, we just don't see it. So we don't do it.
Okay, yeah, it sounds like you kind of have the same opinion as the person asking the questions, that it's adding another step when there's not a problem there to begin with, and some aren't used to it. Todd, how about you?
Yeah, and I would say too that it's not something we do. With the exterior insulation, I guess it is another step. It is more expense. It's one of the battles that we've chosen not to fight yet with our labor in our market. I think it's a great idea. I think it is the right way to do it. As Steve mentioned, Joe would tell you. I understand the science behind it. In our market right now, it's not extremely practical. A little different than the question, because the question was about zip sheathing, and I don't think Steve or I are using zip sheathing.
No.
Right, but the same question kind of applies regardless. Just when you have that much outboard, when you have that much insulation in your wall. So Todd, I'm curious how you use the exterior continuous insulation. How thick of a board are you using typically?
So in our climate, we're
1 inch
typically
XPS.
using 1 inch XPS, R5, and if you look at the, when we kind of determined that 1 inch thickness, we talked with Joe about it, and we really looked at what thickness of insulation on that exterior will give us will eliminate the risk of condensation in the wall cavity, the potential risk of condensation in the wall cavity. And in our climate zone with the weather extremes, we're pretty much at 1 inch. Now we do get up in our northern part of our market is climate zone 4. So we don't change that for climate zone 4. We have toyed with going to 1.5 inches, but there's a pretty steep cost increase for 1.5 inches. And it throws a few other things kind of out of the commonality of typical sizes like jam extensions. So
right, yeah, you've got the
Yeah,
jams
Todd,
around the
I
windows.
think Todd's absolutely correct, and I think 1 inch is all you need in either one of those zones. I think you're absolutely correct.
Do you see?
you know, I
You
will
know,
make
if you were to try to go to 1.5 inches, do you see there being problems with the fasteners that are available to use? You know, once you get that 1.5 inches plus whatever kind of siding you're putting on.
we've not had a problem with that. I'd be interested in Steve's comment on this. We're typically using, we are frequently using an 046 vinyl siding in our market versus fiber cement, primarily because we're seeing the market interested in low maintenance exteriors. So an 046 vinyl is kind of the premium thickness. It's a very durable product and lasts a long time. I know there's issues with vinyl from an environmental standpoint, but we're using 3-inch roofing nails for fastening siding, and we're actually sheathing our exterior frame wall with 1/2 inch OSB before we put the 1 inch of foam board. Our foam board fasteners are actually button cap fasteners, and we can get up to a 2.5 inch fastener on the Bostitch button cap guns that we use. So that's what we use to attach the foam. It actually works really well because we have our framers put the button cap fasteners and hit the studs when they're attaching the foam, and that becomes the identification line for the siding contractor to make sure he's on a stud when he installs the siding. For fiber cement, for fiber cement, it's a whole different ball game. Steve, when you're doing SIPs, I don't know how you attach your fiber cement, but I know for us, the fastener length and what most of the fiber cement manufacturers specify really throws us into almost using a framing nail gun for attaching fiber cement to get it into the stud.
Yeah, and you know, I don't want to pick any side of one industry, but we'll use fiber cement. We'll use it. If I don't have to, I guess I can say brand names on here. I'll use the LP Smart Siding. We get far better, for us, we get far better performance and installation with the LP lap than we do with the Hardy.
What kind of material is that?
It's a composite. Yeah, it's almost like an OSB, but it's not, and it carries the same warranty as the fiber cement. So we like it better. I mean, there have been, it comes primed. You can get it in colors. If you sat them side by side and didn't look on the back of them and stood 10 feet away, you probably couldn't tell the difference between the two.
Right.
And it's easier on the saws, and when you pick it up in the middle, it doesn't break. So we like it better.
All right. So one more question. We're getting back into we talked a little bit about the Steve, for your attics, they're all conditioned, unvented.
Right.
So this question has to do, and I'm not sure if the person who wrote this is dealing with the same codes as you are, but they say, would a supply-only duct line into an unvented attic or sealed crawl space be sufficient to manage moisture load levels in these spaces? The goal is to support the proper design of these assemblies while eliminating a code compliance complication, need for 15-minute thermal barrier or equivalent when using spray foam in attics or crawl spaces. When allowing the lesser ignition barrier or equivalent performance, all code compliance reports indicate air in the attic or crawl space is not circulated to other parts of the building. So they're asking if you don't have a return from those spaces, if you only have a supply, you know, they're kind of trying to you know, see if they can, if that would be covered, you know, that may make them not covered by this requirement as far as, or it would make them meet the requirement that the air in the attic and crawl space is not circulated to other parts of the building. Do you have any
You know,
thoughts on that,
we
Steve?
circulate. The only answer I can give is that we have supply and return. No matter where it is, if there's supply going in, there's got to be a return somewhere. There's got to be. You can't just keep pumping air into a space and thinking, especially in a high energy envelope home, you can't expect for it to bleed out into the rest of the house. It probably will, but we just don't take that chance. If we supply air, which we do, into the attic space, then we'll have a return into it. And you know, a lot of guys have duct blaster tests where they make sure that their HVAC system doesn't bleed out. If ours bleeds out in a conditioned attic space, we don't care. That's a little bit better for us. Now, we don't try to have it do that, but if there is a slight air leak, if it's not sealed exactly as tight as it needs to be, for us, it really doesn't make any difference. But I think they're asking if you just pump air in and don't return it back, is that going to make you comply? I don't think so. I think you've got to circulate that air, you know, from one place to the other.
All right.
And I can speak to that in our market. You know, I think a lot of that compliance, and I think this question might be geared toward the code language that basically says if a space is a plenum, then it has to have certain flame and smoke ratings, and that's probably the 15-minute thermal barrier note
Right.
there. So I can tell you from our experience, I'm going to tell you the opposite of what Steve said. For us, we do the majority of our crawl spaces are sealed and conditioned crawl spaces, and we only supply air to the crawl space. And we rely on that leaking back into the house in a random way, I suppose. It's worked very well for us. So we monitor the humidity in the crawl space. We give the homeowner a means to monitor the humidity in the crawl space. We size those supply ducts based on the advanced energy crawl spaces specs that they developed years ago in North Carolina. If we spray foam an attic and condition that, we're going to do the same thing. We're just going to put supply air into there, and we're going to let it bleed back into the rest of the house. But, you know, again, I think this is a good illustration of, hey, there's not a right way to do everything. I mean, some builders,
that's
like
exactly
Steve,
right.
I may have an inspector that's a little more sensitive to, oh, if you put a return in that crawl space, now it's a plenum and everything has to be 15-minute fire rated or smoke rated, and then that becomes an issue. We have put returns in crawl spaces when we've needed additional airflow or had a particular issue with humidity that we needed to deal with to attempt to rectify that with the AC system. I think a lot of that, though, depends on your local inspector and how they interpret that code language in the IRC. A lot of foam manufacturers now, their foams don't require the extra coating to prevent, I don't know what it is, ignition barrier, I think. So a lot of the new foam formulations don't require an additional ignition barrier, and they'll have an ESR report that you can give your inspector to show that.
Okay. So there are a variety of ways to kind of deal with that issue, depending on what kind of building practices you're already using and what best integrates into your plan. I want to ask are there any particular technologies that you've been excited to use but you haven't found an opportunity to integrate into one of your one of your builds couldn't quite convince the consumer of the value, or maybe it just didn't apply based on their needs? Anything that you're kind of really hoping you're going to be able to try out soon?
We'll try most anything. And in fact, we do. We'll, you know, our I guess our next project that we're starting, which is a 21 house townhome project, we're going to try to implement some of the Tesla panels on the roof and storage batteries, just to test to see how that works. You know, we all try to build and make the most energy efficient, and our guidelines, of course, under what Todd and I do under the Zero Energy Ready. You know, our homes are prepped and ready for any type of extra piece of equipment that will pull the energy level down. Basically, for us, it's going to be some form of a solar array, because that's probably the best thing that works for us, especially in our area with so much sunshine. But you know, our goal is to use that and try that product on our homes and see what we can do. You know, we get them down as low as we can to begin with, but from that point, we want to see if we can get them down. And the dirty word in our industry is a zero energy home, because we don't know if we can actually build that. You don't know what the usage is going to be by the homeowner. It may be zero for you, but they may plug everything in the world into the house, and the next thing you know, it's not zero energy to them, and you've told them that it is. So we don't use that. We just use Zero Energy Ready, which is our guideline. So that's what we're going to try to do. We're going to use some solar panels and see how near zero we can get.
So has that been based on your customers? Did they come to you with that idea, or did you kind of talk to them about the whole Zero Energy Ready idea and how this is kind of the next step to take?
Well, in our, most people, you know, Energy Star kind of started the industry for what we do, and actually we were a 2004 Excellence in Energy Performance winner. We got a phone call one day and said, "Hey, you need to show up at the program. You're getting an award." We didn't even apply for it. No, we have no idea how we got it, but we got it anyway. But the
that good.
The goal was, it was nice. The goal was to build a home that actually performs. And like I told you before, in our industry, for the workforce, it's for that buyer that has the least amount of expendable income at the end of the month. So in doing this, the solar has always been there. It's always been something we wanted to do, but what hasn't been there has been the battery backup or the storage. It didn't work when they first started. I mean, we had battery backups, but it just wasn't any good. And we understand the Tesla product is a superior product, and we just want to try it. Now, the homeowners, they like solar, but with battery backup, this is going to be something new. This is, I guess that's the part that we want to try and see how it works.
Great. Todd, anything you're looking out for on your horizon as far as
we've
technologies
got a couple.
You'd like to use?
We've got a couple of technologies that, I guess just to give a little background, we're incorporating solar into many of our homes these days, primarily in the form of solar shingles on the roof, because most folks that we've worked with tend to like that or favor that aesthetic appeal. One of the elements that we're looking at incorporating into our homes is the Insurance Institute's disaster, what is it, Fortified Home?
Fortified?
The Fortified program. So we feel like there's some demand in our market that will respond to that, and we feel like it's another element that we can add to differentiate. It's not really doesn't have much to do on the energy efficiency side, but definitely has a lot to do with the durability side of things.
Yeah,
So
absolutely.
that's probably the next thing on the horizon.
Yeah, that's becoming more and more of a, kind of the next thing that people are looking at is that resiliency, that kind of disaster readiness, especially in your area where, you can kind of, there's no telling what kind of natural disaster might find you.
A good example today that makes me feel probably a little more like Steve in Texas is my ninth grade daughter just texted my wife today and said she's one of 7 people in her classroom because they sent a note out to parents saying, if you want to come pick up your kid because of the tornado warnings today, feel free to come get them. And everybody apparently is a little worried about that.
Wow. Yeah. And tornadoes are tornadoes common in your part of the country?
Yeah, they're not uncommon, but they're not as common as they are out in Texas and the Plain States.
Yeah, they're a dime a dozen here.
Right. I grew up in Texas, and then when I moved to North Carolina, I was up in the mountains in Boone, and they had never had a tornado. And then when I moved there, we had this tornado warning. It's like, we're not supposed to have any up here. What's going on?
Yeah,
right.
Yeah,
right.
Our climate is so strange now, you
anything.
Can't escape any of it. Yeah.
Okay, well, we only have a couple more minutes. I want to get in one last question from the audience. If we can just try to answer this pretty quickly. They say, please describe the roof system you have found to perform the best in your climate zone.
For me, it's we'll use a slant roof or a pitched roof. If it's pitched, we try not to get too much pitch. So I'll stay with a 6 or below, and below I'll go to a 6 or a 5 pitch. We try to stay traditionally in those on a pitched roof. If it's a slant roof, it can be of any slant you want, or shed roof if you want to call it that, different terms. But in any case, for us, 8 1/4 inches thick, because remember, we build structural insulated panels. So that 8 1/4 inch thick panel will not have any heat penetration through it. So for either one of those, here again for us, a 8 1/4 inch SIP panel is the premier performance, whether in pitched or in a slant or panel roof.
Okay, Todd?
And in our market, our most common high performance home is a truss roof, gable, hip, kind of traditional roof with a radiant barrier and R38 blown fiberglass insulation on the flat ceiling. HVAC equipment in another location, so typically in a conditioned crawl space or a basement.
Okay, so you do have vented attics. You're
we do.
Not conditioning your attic. You're just putting your duct and your HVAC system in the conditioned space below.
That's correct. If we're building, we just started building some houses on slab foundations, and what we've done there is we've actually worked with our truss engineers to design a room and chaseways in our attic that we can condition. So we'll design an insulated room in the attic and then chaseways that our duct chases run through so that we can keep our ductwork and heating and cooling system in conditioned space while in a vented attic.
Great. That's an interesting option. Okay, well, I think we're just about out of time. I want to thank our panelists, Steve Brown and Todd Usher. And sorry we didn't get to every question. If for those audience members who have remaining questions, I encourage you to visit the Building America Solutions Center at basc.energy.gov, and you can find out a lot more resources on these types of questions, and you can always send in a question for the next Stump the Chump edition to our website, which, do we have it here? You can visit buildingamerica.gov and send us your questions. I think that's it. Lynn, do you have anything else to wrap up with?
No, thanks so much, Lena, and thanks again to Steve and Todd for being such amazing chumps. We say that fondly, of course. So thank you, everyone, for your time today. And as Lena mentioned, we do encourage you to subscribe to the newsletter if you're not already a subscriber, so you can get the latest information from Building America, from resources to upcoming webinars and those types of things. But we will be posting today's presentation, and the audio file will be available in a few weeks. Otherwise, thank you very much, and have a wonderful week, everyone.
Good to talk to all of you. Talk to you later.